Yeah, let's do one more example on finding eigenvalues and eigenvectors. As I've made a mention of this shortcut, let me show the shortcut again. In my previous video, I've just shown you how to find the characteristic equation. Det A minus lambda I is equal to 0. This would be the characteristic equation. How do I get from this matrix? Just see here, guys. I'll just be going with the shortcut. What that is lambda cube, obviously 3. So lambda cube, then lambda square, 3 by 3 matrix. So lambda cube, then lambda square. Okay, lambda cube, lambda square, lambda, and a constant term is equal to 0. Of course, I'll be finding the determinant. This is a determinant. So lambda cube will have plus, and minus, right? Next, lambda cube coefficient, as I have said, is always 1. Lambda square coefficient would be trace of A. Trace of A is what? 6 plus 3 plus 3. 6 plus 3 is 9. 9 plus 3 is 12. Right? Next, lambda quotient would be the all those minors having the diagonal elements as the minors. Diagonal elements as the diagonal element of the minors. Okay? Yeah. Or usually we called principal leading minors. Okay? We add all the minors. Okay? 6, 2, 2, 3. Right? So 6, 3 is 18 minus 2, 2 is 4. Plus 3, 3 is 9 minus 1 plus 6, 3 is 18 minus 4. Okay. So what I will be getting? 18 minus 4 is 14. There is one more 14 here. 9 minus 1 is 8. Right. 2 14s is 24. 24 plus 8 would be what? 32. 32 with a positive sign. That would be the coefficient of lambda. Next, determinant. I'll be finding the determinant. Now, since there are no zeros in the matrix, I can find determinant using any row I like. This is nothing but the value of det A. Okay, this would be det A. Okay, so how do I find it? 6 into 9 minus 1. Okay. Minus of minus is plus 2. I'm doing with the first row. Okay. So it would be what? 2 3s minus 2 into 3 minus 6 plus 2. Okay. Yeah. Plus 2 into 2 minus 6. That would be my det A. Okay. Yeah. 9 minus 1 is 8. 6 into 8 I will do. 48. Okay. This would be what? Minus 6 plus 2 would be what? Minus 4. So this would be minus 8. 48 minus 8 is 40. Yeah, this would be what? Again with a minus sign, minus. This would be 4 and again a minus 8. Okay. Yeah, 40 minus 8 would be what? 32. Right? So 32 is what I will have as the determinant. Okay, please do it along with me. Anyways, you can refer to my previous video where I made a mention of the shortcut clearly. Okay. So lambda cube minus 12 lambda square plus 32 lambda minus 32. I'll be giving it to the calculator and I'll be getting the roots values for lambda. What I will get the values would be is 2, 8 the calculator will show. Okay. So for which there is a repeated root. So for which what I have to do? I have to use synthetic division to find which one is the repeated root. 1 minus 12. Synthetic division, all of you are aware. 1 minus 12 plus 32 minus 32. Okay. So I'll be choosing lambda is equal to 2. This is 0, 1 minus plus 2. 1 into 2 is 2. So minus 10 is what I will have. So minus 20, right? And this would be what? 32 minus 20 would be what? Plus 12. Okay. Okay. 12 to is 24. I think I made a mistake here with finding the determinant. 9 minus 1 is 8, 48 this is. And this is what? Minus 6 plus 2 is 4. 2 4s is 8. Here also it is what? 2 minus 6. So 2 fours is again 8. 40 minus 8 is 32. It should be 32 if I'm not wrong. Okay. 6 into 9 minus 1. And then plus 2 into minus 6 plus 2. Yes. Plus 2 into 2. 2 into minus 1. Yeah. 2 minus 6. Okay. So minus 1 is right? So it should give me the right answer. So I'll be using synthetic division to find it. Okay, I'll be using the synthetic division to find the roots. Okay, so this is what 6 plus 3 is 9. 9 plus 3 is 12. That's my trace. Now coming to the minors, what I will get would be 6 minus 2 minus 2, 3 is 1 minor. So 6 threes are 18 minus 4. Okay. 9 minus 1 plus 6 threes are 18 minus 4. Okay. So 18 minus 4 is 14. Here also 18 minus 4 is 14. So 28, not 24. I think I've written 24. It's 28. 28 plus 8 would be what? 36. Okay, so this is 36, right? Now 36 minus 20 would be what? 16. And 16 twos is 32. Okay, so I'll be adding this to be 0. I have lambda square minus 10 lambda plus 16 is equal to 0 is what I have. Okay, yeah, for 16, I'll just be finding the roots. 8 and 2 satisfy. 8 lambda minus 2 lambda plus 16 is equal to 0. Guys, I can clearly see here 8 and 2. So 2 is the repeated root, right? 8 is being given here. I've started with one root and the remaining roots are visible. So 2 is the repeated root. So how I will find for lambda is equal to 8. For lambda 1 is equal to 8. A minus 8i into x1 is equal to 0 is what I will take. I will subtract 8 from the diagonal elements. 6 minus 8 would be minus 2. Minus 2 and 2. Minus 2. 3 minus 8 would be what? 3 minus 8 would be minus 5. Minus 1. 2 minus 1. 3 minus 8 would be again minus 5. Okay. This is x1, x2, x3 is equal to 0. This is my eigenvector. Right? Yeah. So again, I'll be reducing it to echelon form. What I will do, R2, I'll subtract from R1. R3, I will add to R1 to get a 0 below the pivot. What is pivot? Minus 2 is the pivot, right? Minus 2, minus 2, 2. Okay. Yeah. Minus 2, minus of minus plus 2 is 0. Minus 5 plus 2 would be what? Minus 3. Minus 1 minus 2 would be what? Minus 3. Right. I'll be adding R3 and R1. So this is 0. Minus 1 minus 2 would be minus 3. Minus 5 plus 2 would be minus 3. I can clearly see two rows are same. X1, X2, X3. I can clearly see two rows are same. So using one row, the other row should be made 0. Right? Yes. So what I will do, I want a 0. Finally, 1 0 here to reduce it to echelon form. So R3 is what? R3 minus R2. Okay. So minus 2, 2, 0, minus 3, 0, 0, 0. Last row would be completely 0. I'll be writing it in equation format. Minus 2x1 minus 2x2 plus 2x3 is equal to 0. Minus 3x2. x1 quotient is 0, guys. Minus 3x3 is equal to 0. Okay. Minus 3x3 is equal to 0. I can take out 2 common. So I'll be have minus 2 common. x1 plus x2 minus x3 is equal to 0 is the first rewritten equation. Second rewritten equation would be x2 plus x3 is equal to 0, which implies x2 is equal to minus x3. I'll be substituting that relation. I'll be substituting this relation in the first equation. So what I'll be getting is x1 minus x3 is equal to 0. Or in other words, x1 is equal to 2x3. right? So I'll be choosing x3 to be some, let x3 is equal to k1 or something I'll be choosing. So x1 would be what? 2k1. X2 would be what? Minus k1. So the vector would be what? x1, x2, x3 now. 2 minus 1 and 1 multiplied by k1. This is how I'll find the first vector. Coming to the second vector, one shot I should get both the vectors. Otherwise, I don't know. I cannot find. Okay, so the matrix would be what? 6 minus 2. This is a 2, right? The root is 2. So I'll be subtracting. If it is minus 2, I'll be adding. 6 minus 2 would be 4 minus 2 and 2 minus 2. 3 minus 2 would be 1 minus 1. And then 2 minus 1. 3 minus 2 would be again 1. Same thing. I'll be just following. R2 would be what? 2R2 plus R1 because opposite signs are there. R3 would be what? 2R3 minus R1. Okay, so what I will be getting is first row, no change. Okay, second row, I'll be multiplying with 2. So anyways, these two are zeros. Second row is what? Minus 4, 2 and minus 2. So if I add, I'll be getting all zeros. Similarly here, I'll multiply this with 2. So this would be 4 minus 2 and 2. Again, I'll be subtracting. Okay, so opposite signs I will have. Obviously, both will be 0. Now, I'll be having this eigenvector along with the matrix. After reducing to echelon form, I'll write it in the format of system of equations. So what it will be? 4x1 minus 2x2 plus x3 is equal to 0. Or in other words, I have to observe here that the rank is 1 and the number of unknowns are 3. Rank is 1 and the number of unknowns are 3. So I'll be choosing n minus r, that is 3 minus 1, 2 unknowns we choose. We choose. Okay, so you choose accordingly. Let x2 is equal to k2, x3 is equal to k3, right? So anyways, 2 I can take common from all. 2x1 minus x2 plus x3 is equal to 0. Okay, yeah, x1 would be what? X1 is equal to x2 plus x3 by 2, right? Yeah, so I'll be putting x2 to be k2, x3 to be k3 and rewriting it in the vector format. Please see here, my vector would be something like this. All the k2 coefficients at one place and all the k3 coefficients at one place. What are the k2 coefficients in x1? 1 by 2 is the k2 coefficient in x1. What are the k2 coefficients in x2? 1 is the k2 coefficient in x2. There is no k2 coefficient in x3, right? Similarly, 1 by 2 is the k3 coefficient in x1. There is no k3 coefficient in x2. There is coefficient of k3 x3 is 1. Coefficient of k3 in x3 is 1. This is how I'll find one shot both vectors. You can ask me, what ma'am, if I have like a rank is 3 and the number of rank is 2 and the number of unknowns are 3. Only one unknown if I choose, I'll be having linearly dependent vectors. I won't be having linearly independent vectors. That's the problem. Okay. I'll be that vector only I will rewrite. Yeah, I will just stop here.